Hello, this is part 2 of the sum and difference identities. We'll focus on more examples. In this problem, we have radians as opposed to degrees. Now, you can always convert this to degrees and solve from then on, but we'll actually focus staying with radians here. So we want to see if we can rewrite pi over 12 as a sum or difference of pi over 3, pi over 4, and pi over 6. Now, it's not immediately obvious, which two we take the sum or difference of. So what we'll do here is that we'll change the denominators here to 12. So for the first term, pi over 3, I can multiply the numerator and the denominator by 4, and I'll get 4 pi over 12. Multiply 3. For pi over 4, we'll get 3 pi over 12. Do the same for pi over 6. Multiply by 2 here, 2 there, we'll get 2 pi over 12. And now, as you can see here, it's actually fairly obvious what we can use to get pi over 12. We can take 4 pi over 12 minus 3 pi over 12. Or we can actually take 3 pi over 12 minus 2 pi over 12. We'll stick with this first pairing here. 4 pi over 12 minus 3 pi over 12, which will give us pi over 12. So, cosine of pi over 12 is equal to cosine of 4 pi over 12 minus 3 pi over 12. And at this point, we can actually simplify our fractions here. 4 pi over 12 is pi over 3, and 3 pi over 12 is pi over 4. Now, all we have to do is apply our difference identity for cosine. So we have cosine of pi over 3 times cosine of pi over 4 plus sine of pi over 3 times sine of pi over 4. And now evaluate. Cosine of pi over 3 is 1/2. Cosine of pi over 4 is root 2 over 2 plus sine of pi over 3, that is root 3 over 2, times sine of pi over 4, which is root 2 over 2. 1/2 times root 2 over 2 will be root 2 over 4, plus root 3 times root 2 is root 6 over 4. And we'll rewrite that as root 2 plus root 6 over 4. Now we want to apply the same process for the next problem here, sine of 7 pi over 12. Now, we actually already know what pi over 3, pi over 4, and pi over 6 is in terms of having a 12 as a denominator. So, we know pi over 3 is 4 pi over 12. Pi over 4 is 3 pi over 12. Pi over 6 is 2 pi over 12. Now, again, we just need a combination of these two, where if we add or subtract them, we get 7 pi over 12. Now, I'm actually looking at the first two pair here. If we add 4 pi over 12 and 3 pi over 12, we'll get 7 pi over 12. 4 pi over 12 plus 3 pi over 12 gives us 7 pi over 12. So we'll use this. So sine of 7 pi over 12 is the same as sine of 4 pi over 12 plus 3 pi over 12. And again, we'll reduce here to sine of pi over 3 plus pi over 4. And then we apply our sum identity. So that'll be sine of pi over 3, cosine of pi over 4, plus sine of pi over 4 times cosine of pi over 3. And now evaluate. Sine of pi over 3 is root 3 over 2. Cosine of pi over 4 is root 2 over 2. Plus sine of pi over 4 is root 2 over 2. Cosine of pi over 3 is 1/2. Now multiply, we'll have root 3 times root 2 over 2 times 2, which is root 6 over 4, plus root 2 over 2 times 1/2, which is root 2 over 2. Or I'm sorry, root 2 over 4. And then we'll rewrite that as root 6 plus root 2 over 4. Now here's a different kind of problem here. So if sine of alpha is 3/5 and sine of beta is 12 over 13, where alpha and beta are between 0 and pi over 2, evaluate sine of alpha plus beta. So we're going to address this part first here, that alpha and beta are between 0 and pi over 2. So here is 0, and that's pi over 2. So that means that our angles are in the first quadrant. If you remember, all students take calculus, that means every trig function here is positive. So we don't have to negate anything. Now let's continue. So we'll rewrite sine of alpha plus beta as sine alpha cosine beta plus sine beta cosine alpha. Now we already have sine alpha and sine beta, but we need to find cosine beta and cosine alpha. So then cosine beta and cosine alpha. So we'll find cosine beta first. So we already know that sine beta is equal to 12 over 13. So we just have to create a right triangle that mimics that proportion here. So we'll say this angle here is beta. Excuse that. This angle here is beta. Opposite will be 12, and the hypotenuse will be 13. And we just have to find the missing side of the triangle. Now, you can use the Pythagorean theorem to find the missing side, but if you can recognize this type of triangle, it is a 5, 12, 13 triangle. So that means the missing side is 5. So cosine of beta will be 5 over 13. Right here. So now we do the same for cosine alpha. We know sine of alpha is equal to 3 over 5. So we just have to recreate our right triangle with the same proportions. We'll say this is alpha, so opposite is 3, hypotenuse is 5. And again, you can use the Pythagorean theorem to find the missing side, but this is a 3, 4, 5 triangle, so this missing side will be 4. So cosine of alpha will be 4 over 5. So there we go. We have every piece of the formula. So now all we have to do is plug and chug. So we'll start with sine of alpha. Sine of alpha is 3 over 5. Cosine of beta is 5 over 13. Plus sine of beta is 12 over 13. And cosine of alpha is 4 over 5. So we just have to multiply each term. So we have 3/5 times 5 over 13. That is 15 over 65. Plus, and then these two fractions will multiply to 48 over 65. So we have a common denominator, 65. Numerator, we just have 15 plus 48. And that will give us 63 over 65. And that's our final answer. So that covers just about everything with the sum and difference identities. So I hope this video helped you guys out.